All right, guys, we've got some inequalities word problems coming at you here. Again, word problems are easier for me to do on those worksheets, so I'm going to film there, but here we go, some word problems. I've got 5 here on the front. We'll see how many we can get through. Okay, so number 1. Keith has $500 in his savings account at the beginning of the summer. He wants to have at least $200. I'm going to underline that, that's important. At the end of the summer, he withdraws $25 per week for food, clothing, and movie tickets. How many weeks can Keith withdraw money from his account? All right. So again, if you guys watched my other word problem videos, I love to focus on this question at the end. That question at the end tells you what your unknown value is, right? We know a whole bunch of information about Keith and his summer spending, but what we don't know about this scenario is what it's asking. How many weeks can Keith withdraw money from his account? So that is going to be defining my variable. X is going to be the number of weeks. And so the other part is, right, when we went over word problems before, they were all equations. And as I said, it's helpful to start with the total and that sort of thing. But with inequalities, we have one extra thing to worry about, right? With equations, right, they all have an equal sign, and we don't really have to worry about that, right? They're all equals. But for inequalities, there could be 4 options. It could be greater than, it could be less than, greater than or equal to, less than or equal to, right? There's lots of options, okay? And so we have to use context clues here to kind of tell us which one of those it's going to be. And that's why I underlined this at least $200, okay? The word at least, the words at least are going to tell us what inequality symbol that is, okay? And that's might be tricky because when you see the words at least, I think maybe right least and less than are kind of within the same like word family, right? But that's actually not going to be that, okay? Because think about this. Think about Keith, okay? Keith is summertime. He's got $500, and he wants to have at least $200 at the end of the summer. So just think about, there's 3 options here. So if he has more than $200 at the end of the summer, he's going to be happy, right? He'll be happy if there's more than $200. If there is exactly $200, that's okay, right? It's at least 200. That's the lowest amount he can have. But if he has less than $200, he's not going to be happy with himself because he overspent. He wants to have at least $200. So 200 is the lowest. He can have higher than that. He can have that exactly, but he can't have lower than that. So how we would represent that is he wants to have greater than or equal to $200 at the end of the summer. So the words at least, it's kind of backwards from what you'd think, but at least implies that it's greater than or equal to that amount. Okay, and that's going to kind of serve as my total because that's like the final number in this scenario. And that doesn't exactly follow the total. The total number is the biggest one in the problem, but we'll think about what this is saying, okay? Because it's going to kind of fit logically within what it says here. So again, what does it say? It says he has $500 at the savings account at the beginning of the summer. He wants to have 200 at the end, but what's he doing with that $500? He withdraws $25 per week for food, clothing, and movie tickets. Good for Keith. That's great. Living on a budget. So he has $500 there at the start of the summer. Okay. And from that, right, from that 500, he's taking out each week $25. Okay. So this is actually going to be subtraction, right? That word withdraws, again, if you're not familiar with money terms or banking terms, that just means he takes from his account, his savings account, he takes $500 out. Okay. So that $25 is being subtracted from that 500, right? But it's not just doing it one time. It's $25 per week, right? And again, I said that when that question at the end, how many weeks, that's my unknown amount, right? I don't know how many weeks he's going to take it out, but $25 per week. So that's going to be 25x because it's $25 for each week or times the number of weeks that he can take it out. And that's what we're figuring out. That's what it's asking. How many weeks can you withdraw money? So that's my equation. The $500 savings minus $25 per week has to be greater than or equal to that $200 that he wants to have at the end. I'm going to solve this, okay? And I'm going to solve it for x to tell me how many weeks it is, okay? So I'm going to start by minusing this 500 because it's positive 500. I do that, and I'm left with negative 25x is greater than or equal to negative 300. And so that's step 1. Step 2 is to divide by this negative 25. Okay, and remember your inequality rule. When you divide or multiply by a negative to both sides, you have to flip around this inequality sign. Okay, so my answer is actually going to be x is greater than or less than or equal to, 12. X is less than or equal to 12 weeks. So what is that saying? That's saying that he can withdraw money from his account. He can withdraw this $25 for 12 weeks or less, right? It would be good if he withdrew for less than 12 weeks, right? If he withdrew for 10 weeks, he would end up with more than the 200 that he wants. But what it's saying is x is less than or equal to 12. If he withdraws $25 per week for exactly 12 weeks, he'll end right at that $200 amount that he wants. So that's helpful for him to know that he can sustain this budget for 12 weeks to help him reach his goal. Okay, so that's number one. Number two, a taxi charges a flat rate of $1.75 plus an additional 65 cents per mile. If Erica has at most $10 to spend on a cab ride, how far can she travel? Okay, so again, those words at most, again, kind of the opposite of the at least up here, okay? And then what is it asking? It's asking how far can she travel, okay? And that's going to be in terms of miles, okay? Because that's what it says up there. That's my distance unit, miles, okay? So that's my unknown amount is the number of miles she can travel, okay? And again, I'm given all this information, and I'm told she has at most $10 to spend. Okay, so at most $10. So think about that too. If she spends less than $10, she's good. If she spends exactly $10, that's still okay. That's all of the money that she has, but that's still okay. She can spend exactly 10. But if she goes over $10 on her cab ride, then no good. She doesn't have that. So she's trying to figure out, okay, at most $10. I want this cab ride to be less than or equal to $10. So again, when you think of the word most, you probably think greater than, but again, it's just like the one above. When you see the words at most, that means less than or equal to. Okay, so she wants her cab ride to be less than or equal to $10. Okay, and then what does it say about the charges of the cab ride? Well, the flat rate of $1.75, again, she's going to pay that, no matter how many miles she rides. Okay, so that does not have an X with it, because that has nothing to do with the amount of miles, plus an additional 65 cents per mile. Okay, so that's going to be 0.65X, right, because it's 65 cents for each mile. So I begin to solve this then, and I subtract $1.75 from each side, and I get 0.65X is less than or equal to $8.25, okay? And then my last step, I divide by that 0.65, okay? And I get X. I don't have to flip my inequality sign here because I'm not divided by a negative. So it remains less than or equal to, so she can ride less than 12.7 miles. And chances are they do it for the whole mile. So we wouldn't round that up to 13 either. So let's just even say just 12. Okay, usually, you go with the whole numbers with that sort of thing in this scenario. So we'll just say less than or equal to 12 miles. So she can ride less than 12, so like 5 miles, 8 miles, 10 miles, she's good. 12 miles exactly, she's fine. 13 or above, she doesn't have the money for it. Number 3, Chris wants to order DVDs over the internet. Each DVD costs $15.99, and shipping the entire order costs $9.99. If he can spend no more than $100, how many DVDs could he buy? What we don't know, how many DVDs? So that's going to be X is going to be the number of DVDs. Hopefully you guys still know what a DVD is. That's not too outdated. Anyway, he can spend no more than $100, okay? And so no more than $100. What does that mean? No more than. So again, think about our scenario. If he spends less than $100, good. If he spends exactly $100, that's fine. That's all the money he has. But if he spends over $100, no good. He can spend no more than that. Okay, so 100 is the maximum. Okay, so he wants his movie order to be less than or equal to that total of 100. Okay, so no more than is kind of the same as at most. So no more than is going to be less than or equal to. And then what's going to add to give me that 100? Well, it's going to be the DVD costs plus the shipping cost. Okay, so each DVD costs $15.99. So $15.99, that has an X with it, okay, because each DVD costs $15.99. So for each additional DVD, it's going to be that extra $15.99. And then shipping the entire order costs $9.99. And so that's the shipping cost. Doesn't have to do with how many DVDs. He could buy one or he could buy 7, whatever. It's still going to be that $9.99. So I start from here. I minus the $9.99 from both sides, and I have $15.99 is less than or equal to, that's going to give me $90 and a penny. And then I divide by my $15.99 cost. Aren't these decimals fun? And I get X is less than or equal to, definitely need my calculator here. 5.629 is my amount exactly, okay? But again, you can't buy 0.629 of a DVD. So we have to round that, and we're going to round it down to just 5. If we rounded it up to say he could buy less than or equal to 6 DVDs, then that would be a lie because he can't afford exactly 6 DVDs. That would be just above what he can afford. So we have to round it down to say 5. X is less than or equal to 5 DVDs to be able to afford that. Okay, 2 more. Allison practices her violin for at least 12 hours per week. Wow. She practices for 3/4 of an hour each session. If Allison has already practiced 3 hours this week, how many more sessions remain for her to meet or exceed her weekly practice goal? Okay. So some hidden numbers in here, okay? It doesn't say the digit there, but 3/4 of an hour. 3/4 you can write as the fraction of 3/4. I'm actually going to write that as 0.75. That's going to be a little bit easier for me to do in my equation. So 0.75 hours, that's how much each session is worth, okay, or how much she practices each session. And what I don't know about this scenario is how many sessions, or how many more sessions, okay? So what does it tell us? It says she practices her violin for at least 12 hours per week. So again, at least 12 hours. So she wants to do 12 or more. So she wants her amount of hours practiced to be greater than or equal to 12. Okay? And then, what does it say? She has already practiced 3 hours this week. So her weekly amount that she practiced is going to be the 3 that she already did, plus her mystery amount of 3/4 of an hour sessions. Okay, again, we know that's 45 minutes, but we'll keep it in terms of hours, so that'd be 0.75 hours. Okay. 0.75 hours, but again, it's each session. So we don't know how many sessions she needs to practice at that length. So it's going to be 0.75x. So then we set that up and we solve. So it's minus 3 from both sides. And that's 0.75x is greater than or equal to 9. And then I divide by 0.75, and I get an answer of x is greater than or equal to 12. I believe 12 sessions. So for her to meet her 12-hour goal, she already did 3 hours, so we can subtract that from that. And so, okay, out of her session, she needs to account for 9 more hours to meet her goal. Okay, and so if we divide that by how long each session is, we get that she needs to practice for 12 more sessions or more, right? Because she can go over, she's really killing it on the violin and wants to go more than her 12 hours per week, then she can do that. Okay, last one. Pet Supplies makes a profit of $5.50 per bag on its line of natural dog food. If the store wants to make a profit of no less than $5,225, how many bags of dog food does it need to sell? We're not told a whole lot of numbers here, okay? Again, what's our unknown amount? Our unknown amount is how many bags of dog food. That's what it's asking for. So they make a profit of $5.50 per bag. And what do they want? Their goal is to make a profit of no less than $5,225. So again, if they get below that, they're not going to be happy, okay? They're not going to be happy if it's below that amount. They want $5,225 or more dollars, okay? So they want their profit to be greater than or equal to $5,225. And it doesn't tell us anything. We don't have like an additional fee or anything or anything that's going to be added on to this. So it's just going to be this one amount, this 550 X, because it's 550 for each bag of dog food. So for every bag of dog food they sell, that's an additional 550 profit for them. And so we solve this, right? Just one step to solve this. I divide by 5.50. So they have to sell greater than or equal to 950 bags of dog food to make that profit goal. Again, if they sell more than that, that's good. But that's their minimum. They need to sell 950 or more. So there you have it. Hopefully that makes sense. And thank you.